Assalamualaikum warahmatullahi wabarakatuh. It's a pleasure to meet you again at MA3051. I am Edy Tri Baskoro from FMIPA ITB. Today's lecture is about minimum connector problems. Enjoy listening. At the end of chapter 1, we give you one of famous applied problems in graph theory, which is the shortest path problem. Now at the end of chapter 2, we will discuss on another famous applied problems of graph theory, which is minimum connector problem. This problem is also faced in various contexts and real-world activities. We start by stating the problem. Given a weighted graph G, find a minimum spanning tree. Okay? For example, we have the following problems. A telecommunication company wants to install a telephone line networks connecting 5 cities, which is Bandung, Jakarta, Surabaya, Tegal, and Cilacap. And the problem is find a network or spanning tree with the minimum cost. And we are given the data of distances between these 5 cities as seen in this figure. Then if we draw in the graph setting, we will have a complete graph with 5 vertices with weighted edges as a distance between these 2 vertices. And now our task is to find a network or spanning tree which connecting these 5 cities with minimum cost. In this lecture, we will give you 2 algorithms to solve this problem. First, Kruskal algorithm, and then second, Prim's algorithm. The Kruskal algorithm has 3 steps, like in this following diagram. In principle, Kruskal algorithm, in every step, we have to choose an edge with smallest weight so that all the selected edges not creating a cycle. Okay? Now let's apply the Kruskal algorithm. First, we look for an edge with the smallest weight here. So in that case, we will have that this edge with the smallest weight. And then we look for another edge which have the smallest weight. And then we have this one is an edge with the smallest weight. And then the next step, we find another edge with the smallest weight. This is the edge with the smallest weight. Then, next step, we have that this edge is the smallest weight, but if we select it, then we have a cycle here. So, we cannot select this edge. We have to find another edge, and we found that this is the next smallest weight. But again, this edge will create a cycle in our graph. So we cannot select this edge. And then it comes to this edge. Again, this edge cannot be selected because it creates a cycle. And then the next step, we find that this edge is the smallest one. And this edge not creating a cycle, therefore we can select it. So in the final result, we have a spanning tree with the smallest weight. Next, we will give you another famous algorithm we call Prim's algorithm. This algorithm has 3 steps. In the first step, we choose any vertex and connect it to the nearest vertex. And then, second, connect the nearest vertex that is not connected to those already chosen. And the last step, repeat the step 2 until all vertices have been connected. Now we apply this algorithm to our graph. So first, we choose any vertex. Let's suppose we choose this vertex, Tegal vertex, and then we connect this vertex with the nearest vertex. So which is the nearest vertex is this vertex, Cilacap city vertex. Yeah. And then we have to find another nearest vertex. Yeah. So in that case, we will have that Bandung is the nearest vertex because we have the weight here is 202. Yeah. The other weights are bigger than 202 from these vertices, yeah, from the previous vertices. And then next we will find another nearest vertex, the new nearest vertex, which is Jakarta, because Jakarta is nearest from Bandung and the weight is 180. Yeah. Next, we will find Surabaya is the nearest vertex from the previous selected vertices. So in the final step, we will have a spanning tree of this graph with a minimum cost. Okay, this is the end of this lecture, and Assalamualaikum warahmatullahi wabarakatuh.